Hello students, how are you all? I hope you all are fine. See here some questions are written. These questions are you from derivative topic, differentiability topic. So today we will discuss how you will differentiate these functions. So you can see here trigonometric inverse functions are written. So we will learn how you will write the derivative of a trigonometric inverse function, how you will differentiate given function. Before this video we had learned how you will differentiate some function in which a trigonometric function are there, algebraic function are by applying product rule, division rule, function of function rule. Okay, so let us see how you will solve. Okay, so see first read the question. Find dy upon dx in the following function. So here functions are written and you can see these functions are inverse trigonometric function. So we will find dy upon dx. So let us see. So here you can see first one is y is equal to sine inverse 2x upon 1 plus x square is there. Okay. So there is the derivative of a inverse trigonometric. As you know that inverse trigonometric function of sine inverse x is what 1 1 upon square root of 1 minus x square is there. Okay. So but here we will not apply that, and that here we will put x value here something, so that sine inverse get cancel out. Okay, so here let us see if we put x is equal to tan theta. Suppose if we put here x is equal to tan theta, then theta will be tan inverse x, and function will become sine inverse 2 tan theta upon 1 plus tan square theta. So you can see here now, as you know that this is the identity of sine 2 theta. Okay, you had learned in 11th class. Now what you will write here, sine inverse sine 2 theta, here you will write. Now see, sine inverse get cancel out, what will come, 2 theta will come. In place of theta you will put the value what, tan inverse x you will put. Now y is equal to, now find derivatives. Dy upon dx is, now as you know that derivative of tan inverse x what, x is what, 1 upon 1 plus x square is there. Then what will come, 2 upon 1 plus x square will be the dy upon dx of given inverse trigonometric function. Okay, to see here how you will write the derivative of a given trigonometric function. Okay, I hope you have understood. Now let us see the next one. Next one is what? Next one is what? Second one. Second one is what? Y is equal to tan inverse 3x minus x cube upon 1 minus 3x square. Okay. Now if we let theta is x is equal to, here x is equal to, we put in all inverse trigonometry we will put x something. Okay, so see here we will put x is equal to tan theta, then theta will be tan inverse x. Okay, same thing we will write here. Then y become what, tan inverse 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Okay, see this. Now as you know that this is the identity of what, tan inverse tan theta tan 3 theta, identity it is. Okay, now if we cancel it this, what will come, 3 theta will come, and in place of theta you will write tan inverse x. Now dy upon dx, now we will find the dy upon dx will be 3 into 1 upon 1 plus x square, then 3 upon 1 plus x square. So this will be the dy upon dx of given function. So see here how you will write the dy upon dx of a given inverse trigonometric function. Okay, I hope you have understood how you will write the solution, how you will find the dy upon dx. Okay. Now let us see the third one. So for writing the solution of third one, I have to erase. I hope you have noted down. Okay, now let us see the third one. Third one is what? Y is equal to cos inverse 1 minus x square upon 1 plus x square. Now see, if we put x is equal to again tan theta, it will become the identity of cos 2 theta. Okay, so let here x is equal to tan theta, then theta will be tan inverse x. Now y will be cos inverse 1 minus tan square theta upon 1 plus tan square theta. Now as you know that this is the identity of cos 2 theta, then cos inverse cos get cancel out, and in place of theta what you will write? Tan inverse x. Again, why is this? Now dy upon dx will be what? 2 into 1 upon 1 plus x square. It means 2 upon 1 plus x square will be the dy upon dx of given function. So see here how you will write the dy upon dx of a given inverse trigonometric function. I hope you have understand. Okay. Now let us see the fourth one. Fourth one is what? Y is equal to sine inverse 1 minus x square upon 1 plus x square. So again you can see here this thing and this thing are same thing. So what we will write here? Let x is equal to tan theta, implies that theta is equal to tan inverse x. Then y will be what? Sine inverse 1 minus tan square theta upon 1 plus tan square theta. Now this is the identity of cos and cos and sine, how it will cancel out. Okay, so let us see how will you will write cos 2 theta. So this is the identity of cos 2 theta, but here sine inverse is there, so how you will write? Now see, sine inverse, this can be written as cos pi upon 2 minus 2 theta. Okay, sorry, sine pi upon 2 minus, as you know, sine pi upon 2 minus 2 theta is what? Cos 2 theta. Then sine get cancel out, y will be what? Pi upon 2 minus 2 theta. Now dy upon dx what will come? Constant value is 0 and 2 theta is there. So let us write first 2 theta value. Okay, y is equal to pi upon 2 minus 2 theta is what? Tan inverse x. Now dy upon dx will be what? Pi upon 2, derivative will be 0 because constant value it is. Now minus 2 into 1 upon 1 plus x square, it means minus 2 upon 1 plus x square will be the dy upon dx of given function. In this way you will differentiate. So see here how you will find the dy upon dx. I hope you have understood how you will write the solution of this. Okay, now let us see the fifth one. So that was fourth one. Now let us see the fourth one. So for writing the solution of fifth one, I have to erase. I hope you have noted down. Okay, now let us see the fifth one. Fifth one is what? Y is equal to cos inverse 2x upon 1 plus x square. Now if you will put x is equal to tan theta, then it will become the identity of sin 2 theta. Then again situation will come how cos inverse and sin will cancel out. Okay, as last question that ki sin inverse and cos how you will cancel out. So what we will do in place of sin 2 theta, we will write cos pi upon 2 minus 2 theta. So let us see. Let x is equal to tan theta, then theta is equal to tan inverse x, then y is equal to cos inverse 2 tan theta upon 1 plus tan square theta. Now see, this has become the identity of sin 2 theta. Now sin 2 theta can be written as cos inverse cos pi by 2 minus 2 theta, cos pi by 2 minus 2 theta. Then cos get cancelled, y is equal to pi upon 2 minus 2 theta tan inverse x. Again, if you will find dy upon dx, then what will come? Constant value will be 0 to 1 upon 1 plus x square. It means minus 2 upon 1 plus x square. Then dy upon dx will be what? Minus 2 upon 1 plus x square. So see here, in this way we will write the dy upon dx. See here, I hope you have understood how you will write the solution, how you will find the dy upon dx of fifth one. Now let us see. Now let us see the sixth one. Sixth one is what? Sin inverse bracket 2x square root of 1 minus x square. Sorry, here y is equal to 6 1. Y is equal to, okay. Now see, this time we will not put x is equal to tan theta, because if you will put here sine, then cos will come and sine. 2 sine theta and cos theta become sine 2 theta, then sine get cancelled out, then we will find accordingly. So let here x is equal to sine theta, then it gives theta is equal to sine inverse x, then y is equal to sine inverse 2 sine x square root of 1 minus cos square x, then y is equal to sine inverse 2 sine x. Now 1 minus square root of 1 minus cos square is what? Sorry, here we have to put sine na? Cos x, y is equal to sine inverse x, sine inverse sine 2x, sorry 2, what I am doing here, here we have to put theta, okay, theta, okay. So here what will come? 2 theta will come, then sine get cancelled out, what will come? Y is equal to 2 theta, then y is equal to 2 sine inverse x can be written, okay. Now if you will find the dy upon dx, then what will come? 2 into 1 upon 1 minus x square root, then dy upon dx can be written as 2 upon 1 minus x square root. So see here, in this way we will write the dy upon dx of the sixth one. Okay, now let us see the last one, seventh one. So for writing the solution of seventh one, I have to erase. I hope you have noted down. Okay, now see the seventh one. Seventh one is what? Y is equal to sec inverse 1 upon 2x square minus 1. Okay, so now see here. This time if you put x is equal to cos theta, then it will become the identity of what? Cos 2 theta. Then 1 upon cos 2 theta will come. Then 1 upon cos 2 theta can be written as sec 2 theta. Then sec get cancel out. In place of theta, we will put the value accordingly. So here we will write let x is equal to cos theta. Then theta gives cos inverse x. Then y is equal to sec inverse 1 upon 2 cos square theta minus 1. Then what will come? Sec inverse 1 upon this is the identity of cos 2 theta. Okay. Then this can be written as sec inverse sec 2 theta. Then sec cancel, 2 into theta value is what? Cos inverse x. Then dy upon dx is 2 into derivative of cos inverse x is what? Minus 1 upon 1 minus x square, square root of 1 minus x square. Okay. Then dy upon dx can be written as minus 2 upon square root of 1 minus x square. So see here, in this way we will write the dy upon dx of last one also. Okay. So I hope you have understood how you will write the dy upon dx of the last one, how you will write the solution. And I hope you have understood how you will write the dy upon dx of all the inverse trigonometric function here, how you will write the solution. Okay. Now, if you have liked the video, then share and subscribe it. And if you have any query, then comment in my comment box. And if you are facing any doubt in any question, then take pic of that question, send to my WhatsApp number. WhatsApp number already given in my channel. Okay. So till now, wait for the next video. Next video, we will come some more question of differentiability. Question will be different. Okay. So till now, have a nice day. Goodbye, and wait for the next video.